Welcome back. So, why are we talking about this space stuff? Well, because we do face a threat from the from impacts from the space debris, whether it's meteorites or asteroids. Uh, they do affect the geology of Earth. So let's talk about it. So they don't. What's interesting is that the space debris, it doesn't actually have to hit the Earth to cause damage or to affect the geology. It can, that's an impact, but it can also create something called an airburst. It's when the object explodes in the atmosphere from about 7 to 30 miles above the Earth's surface. This is actually how nuclear weapons work. When we drop a nuclear bomb for the two times that we did it, Hiroshima and Nagasaki, it actually didn't hit the Earth and then blow up. It actually blows up in the air. The reason for that is that when it explodes out, it kind of acts like. So if it explodes, all that explosion, that energy kind of comes out this way, and once it hits the ground, then it moves laterally. It's almost like a shovel, like just. That's why they blow it up in the air. Anyway, so an airburst of a space debris, of an asteroid or meteorite, or I guess meteoroid at that point, if it's in the atmosphere, can do substantial destruction. Some examples that we'll talk about momentarily would be the Tunguska event, as well as what happened in Chelyabinsk. But we can also have impacts that is when the material hits the Earth, the object, whatever it is structurally strong enough, it's moving fast enough, it's big enough to break through the atmosphere and hit. Some examples, there are many, but we'll talk about real quick the Behringer crater in Arizona, what happened at Chesapeake Bay in Virginia, and the Chicxulub impact site. So again, meteoroid, meteorite. But when you do get an airburst, we're looking kind of in this area of the atmosphere, the troposphere. I mean, they can happen a little bit further out, but your bigger space material is probably going to make it pretty far before it blows up, before there's an airburst. And again, it can cause a lot of damage. So again, every day there's 25 million different meteoroids into the atmosphere, but if you add all that up, it's about 100 tons of dust and sand-sized particles. So again, it's a lot of material, but it burns up. So every day there's a bunch of stuff hitting the atmosphere. It usually burns up. About once a year, you get a car-sized meteoroid, which creates a large enough fireball, but it still burns up in the Earth's atmosphere before reaching the surface. Some cool videos of it. It looks scary, but it's not going to hit the ground and impact. However, about every 2,000 years, you get about a football field size asteroid hits the Earth, causes significant damage to the immediate area. And then about once every few million years, an object large enough to threaten Earth's entire civilization comes along. So, yeah, about once a year on the news, you'll see something cool, meteoric asteroid or meteoroid burning up in the atmosphere. About once a year, you'll see that. Cool, but nothing too scary. About once every 2,000 years, you get a big chunk of material that actually hits or does some damage to the Earth, and every few million years, you get that possible end-to-life type asteroid that might hit the Earth. So, when we're looking at all these space rocks then smaller than about 25 meters, which is about 82 feet, will most likely burn up in the atmosphere, cause little or no damage. All right, so that's how big these things can be. Just short of 100 feet, which is pretty big. So 82 feet, it's an 8-story building. Anything that or smaller will most likely burn up in the atmosphere. Most likely. There's always exceptions. When you're looking at asteroids larger than 25 meters, but smaller than 1 kilometer, which is a little more than a half mile, that would likely cause local damage to the impact area. So if that hit, it's going to do some damage to the impact area, but we're not talking about end of civilization. Until we're talking about anything larger than 1 to 2 kilometers, which, over a mile big, that could have worldwide effects. So, most stuff we don't have to worry too much about. So we do keep an eye on all the stuff that's floating out there in space. More on that in a later section. So we do keep an eye on all this stuff. What's interesting to note is at about 2.5 kilometers in diameter, so it's a little over a mile, the largest known potentially hazardous asteroid to Earth is Tautatis, which is scheduled to return back in Earth's vicinity in 2069. So if you're around, watch out. It's not. That doesn't mean that this is going to hit Earth, but it's in a path that's going to bring it pretty darn close. And you never know. In the 40 some years until this returns, things could happen in space. It could get jostled a little bit, pull a gravity here, whatever. It might just, make its way to Earth. So that's the one we're kind of keeping an eye out for that we know of. But there's a bunch of stuff that we don't know of that could just show up all of a sudden. So we're not concerned about every piece of space material. What we're looking at are these acronyms called NEOs and PHOs. So NEOs are near-Earth objects. These are asteroids and comets that have orbits that can bring them into Earth's neighborhood. And not necessarily that they would hit, but just in our neighborhood. A little too close for comfort. But that close for comfort, that neighborhood is 30 million miles of Earth. It's pretty far away, but as far as space is concerned, I mean, space is, vast. Infinite, right? So the fact that anything can get even that close, that's pretty close. That's about the distance between Earth and the moon, I believe. Hold on, pause 1 second. Okay, I'm back. I was a little off. 30 million miles is not the distance to the moon. Distance to the moon is about 240,000 miles. So 30 million miles is about 125 moon distances away, or about a third of the way to the sun. So anything that has a path, a space debris that has a path within that distance of Earth coming into our neighborhood, we classify as an NEO. Again, a near-Earth object. So these are the types of things that we track. But then we also have PHOs, potentially hazardous objects. This is a smaller subset of NEOs whose orbits will come within 5 million miles of Earth. So that's about 20 times the distance between here and the moon. So 20 of those distances. So it's that close, or only about 5% of the way to the sun. So this is, these are the ones that are going to get a little extra close. And they have to have a size large enough to cause significant damage on Earth. So not necessarily life-ending, civilization-ending, but if they hit, they're going to do some damage. And so roughly large enough, so about 30 to 50 meters or bigger. So that's a subsection of NEOs. So here are all known PHOs, all known potentially hazardous objects that may come within 30 million miles of us. And that's kind of the distance basically between the closest Earth and Venus would be, or Earth and Mars. So kind of in this area. So wherever Earth is, that the object, this asteroid, would come within kind of that distance there. So here's a graphic of all of these PHOs. So there's a lot of stuff out there, right? So we're tracking all of this stuff with computers and science. We can track all of these. That's why of all of this stuff, the ones we know of, that Tautatis, which is scheduled to come back in 2069, that's the one we're keeping an eye on. We're keeping an eye on all these things, but that's the one that really may be a big issue. But there are millions or billions that we just don't know of that could also be bigger issues. So the next major kind of event that would impact the Earth, not literally but figuratively, it is virtually certain. The probability is 99% or greater that the next destructive NEO or PHO event will be an airburst. Not a big old impact, because those happen, once in every few million years, but about once every 2,000 years we get something that explodes in the atmosphere. So the next NEO PHO event most likely is going to be airburst. It would burst apart over a city. That poses a much greater threat to humanity than the long-feared kind of planet buster that you see smacking into the Earth on movies. And the reason being is not that this material would hit the Earth. Maybe there's some, if it explodes in the atmosphere, maybe some stuff might rain down on Earth, but it's just the sheer explosion itself, relatively close to Earth's surface, that could cause a shock wave that could destroy houses, blow down trees, break windows. So there can be a lot of damage due to these. It doesn't necessarily have to hit the Earth. Okay. So when we come back, we'll talk about some of those historic airbursts and impacts that I referenced at the beginning of the section: Tunguska, Chelyabinsk, Beringer, Chesapeake Bay, Chicxulub, of course, Chicxulub. So we'll talk about those in just a second.